this video, I'm going to talk about solving quadratic inequalities using an algebraic approach. Example 1. It says graph the solution set x minus 3, x plus 4 is greater than 0. So we're going to solve this algebraically. So first thing we're going to do is we're going to say x minus 3 equals 0. We'll add 3 to both sides, and we get x equals 3. We're going to say x, let's just change the color. I'll do the right side, x plus 4 equals 0. We'll subtract 4 from both sides. We get x equals negative 4. So now we know our test point, or we have to have, thinking about this on a number line, let's make a number line so it can make sense of this. We have 4 first, then negative 4 first, and then 3. So we need to go from, our intervals are going to be, here's negative infinities on this side, and we have stuff in the middle between negative 4 to 3 and 3 to infinity. So our 3 intervals will be negative infinity, comma, negative 4, negative 4, comma, 3, and 3 to infinity. So we want to pick a test point at each interval. So to the left of negative 4, we can say negative 5. We pick any other number you want. Our next test point has to be in the middle. So between negative 4 and positive 3, we can pick anything you want. I'll pick 0. And then greater than positive 3, we can just use 4 or any other number we want. So the next step is just plug in those numbers into our original equation. So we do negative, so I'll just do the work on the side. Negative 5 minus 3 and negative 5 plus 4. So negative 5 minus 3 and negative 5 plus 4 gives me an answer of 8, which is positive. And anything positive is greater than or equal to 0, so this is part of the solution set. Now we test 0. So that would be 0 minus 3 and 0 plus 4. 0 minus 3 is negative 3, and 0 plus 4 is positive 4, and negative 3 times positive 4 gives me negative 12. So this gives me a negative answer. And negative answers cannot be greater than or equal to 0, so that's not part of the solution set. Last interval we want to check is 3 to infinity, so we're going to plug in 4. So 4 minus 3 and 4 plus 4. 4 minus 3 is 1. 4 plus 4 is 8. And 1 times 8 is 8. So that is positive. So that's also part of the solution set. So our solution set will go from negative infinity to negative 4, union (3, infinity), and we are done. Example 2. We're going to solve this also algebraically. We have x squared plus 3x is greater than or equal to 10. So first thing we have to do is we have to move this 10 to the other side. So subtract 10. Subtract 10. So I have x squared plus 3x minus 10 is greater than or equal to 0. You want to factor it next. So you have 1 and 1. 1 times negative 10 is 10, negative 10. Then 3 on the bottom. You want two factors of negative 10 that when I multiply them, I get negative 10, but when I add them, I get negative 3, and those two numbers will be 5 and negative 2. So our factor form would be x plus 5, x minus 2 is greater than or equal to 0. So now I just say x plus 5 equals 0 and solve. So we have minus 5 minus 5. The x equals negative 5. And then we do x minus 2 equals 0. So we're add 2 to both sides. And we have x equals 2. So on the number line, we would have negative 5 to 2. We have 3 sections. I'll highlight each one a different color. So we have negative 5, negative infinity to negative 5, negative 5 to 2, and 2 to infinity. So let's write our first interval first. Negative infinity to negative 5. Negative infinity to negative 5. And we did that one in green. The next one we'll do in yellow, and that'll be negative 5 to 2. Technically, we should be using a square bracket. Then the last one is going to be 2 to infinity. We'll highlight that in blue to be consistent. So now we want a test point. So anything less than negative 5 would be in the negative infinity to negative 5 interval. So we're going to pick negative 6. Between negative 5 and 2, we can pick any number. So I'll pick the easy one, 0. And then from 2 to infinity, anything bigger than 2, I'll pick 3. So all I have to do is plug in and see if it works. So let's check the first one. So we'll do negative 6 squared plus 3 times 6 minus 10. Plug it in the calculator and see what you come up with. So plugging it in, negative 6 squared plus 3 parentheses 6 minus 10, and that gives me 44, which is positive, so that is part of the solution set. Next one, we would do 0, so that would be 0 squared plus 3 times 0 minus 10, and let's highlight that to be consistent. So 0 squared plus 3 times 0 minus 10 is negative 10, and that's negative. So a negative number cannot be greater than 0. So no, this is not part of the solution set. The last interval number we're going to check is 3. So we're going to do 3 squared plus 3 times 3 minus 10. We'll highlight that in blue to be consistent and see if that's in our solution set, which it should be. 3 squared plus 3 times 3 minus 10, and that gives me 8, which is positive. So that is part of our solution set. So we're going to write this in inequality notation now. So it'll be from negative infinity to negative 5, square bracket, union, square bracket, 2 comma infinity, and we've solved our quadratic inequality. Example 3. We have negative negative x times 2x minus 4 quantity minus 24. So first thing we're going to do is we're going to distribute in this negative x. So it'll give me negative 2x squared minus or plus 14x is less than 24. Next step, we're going to minus 24 on both sides to leave us with negative 2x squared plus 14x is minus 24 is less than 0. We're going to divide out a negative 2 from everything to make our job easy. So that would put a negative 2 in front, and we have x squared minus 7x plus 12 is less than 0. We do have to flip the inequality since we did divide everything by 0. So now we just factor what's in the middle. So we have 1 and 1, a negative 7 on the bottom, a 14 on the top, sorry, 12 on the top. And then we think two numbers that multiply to make 12 but add to make 7, that would be negative 3, negative 4. Negative 3 times negative 4 is positive 12, and negative 3 plus negative 4 is 7. So our factor form would be x minus 3, x minus 4 equals 0. So we just solve both sides. That would be x minus 3 equals 0. Add 3 to both sides. We get x equals 3. Same thing on the right side. Add 4 to both sides. And x equals 4. Okay, on a number line, we have 3 and 4. So our intervals will be from negative infinity to 3, 3 to 4, and last but not least, 4 to infinity. Okay, picking a number to the left of 3, we can use 0. Between 3 and 4, we'll use 3.5. And then bigger than 4, we'll just use 5. So now we just plug into our equation. Plug in 0. 0 times 2 times 0 minus 14. That gives me 0. And 0 is not a positive or negative, but 0 is less than 24, so it is part of the solution set. So now we plug in the 3.5, negative 3.5, parentheses 2 times 3.5 minus 14, and that gives me 24.5. And we're asking ourselves, is that less than 0? Okay, now we're going to plug each of our inequalities into our new inequality. We'll say negative 2, parentheses 0 squared minus 7 times 0 plus 12 that would be negative 24. And that's negative. And a negative answer is not positive, so it's not part of the solution set. Now we try the same thing with 3.5. So negative 2, parentheses 3.5 squared minus 7 times 3.5 plus 12. We're asking, is that greater than 0? That's 0.5. So that's positive. And that is part of the solution set. And then last but not least, we tried 5, negative 2, parentheses 5 squared minus 7 times 5 plus 12. That gives me negative 4, which is negative. And no, that is not part of the solution set. So our solution set is just from 3 to 4, and we're done. A rectangle has a length that is 10 meters more than twice the width. Find all the possible widths that result in an area of the rectangle not exceeding 100 square meters. So first, let's make a picture. So we know the area is 100. The width is x. And we'll say for 10 meters more than twice the width, so it will be 2x plus 10. So now we just set up our equation. So it'll be x parentheses 2x plus 10, since we recall that area equals length times width. And that's going to be less than 100. So distribute the x, that'll be 2x squared plus 10 is less than 100. We'll subtract 100 from both sides. And don't forget the x plus 10x minus 100 is less than 0. We'll divide everything by 2. So I'll just leave me with x squared plus 5x minus 50 is less than 0. We're going to factor our new quadratic. We have 1 and 1, negative 50 on the top, 5 on the bottom. So you want two numbers that multiply to make negative 50, but add to make 5. That will be 10 and negative 5. So our factored form just becomes x plus 10, x minus 5. And we set it equal to 0 and 5, find our zeros. So we'll say x plus 10 equals 0. We'll subtract 10 from both sides. We'll say x equals negative 10. We'll say x minus 5 equals 0. We'll add 5 to both sides. And that's going to be x equals 5. So in the number line, we just set up our numbers. Has to be negative 10 and positive 5. So we're going to have 3 intervals. Between 10 and 5, we'll highlight in yellow. Between like infinity and 10, we'll highlight in green. And 5 to infinity, we'll highlight in blue. So let's write them down. Negative infinity to negative 10. Negative 10 to 5. And then we have 5 to infinity. So you want a test point. So anything less than negative 10, that would be negative 11, or anything less than negative 10. Between negative 10 and 5, we can use 0. And then we have 5 and bigger than 5, we can use 6, or any number bigger than 5. So now we just plug into our equation and check and see if it's true or false. So plugging in negative 11. So we have negative 11 squared plus 5 times negative 11 minus 5, 50. We're seeing if that's less than 0. So you have negative 11 quantity squared plus 5 times negative 11 minus 50, and that gives me 16. And that's positive. That's potentially part of the solution set. Remember, we are dealing with a real world situation. And then we can plug in 0. So we have 0 squared plus 5 times 0 minus 50. And we want to see if that's less than 0. So 0 squared plus 5 times 0 minus 50. That gives me negative 50. And that's negative. And that's less than 0. Sorry, the first one should be no. It's not part of the solution set. But this one is. So 0 is in that negative area, which is less than 0. And then we'll plug in 6. 6 squared plus 5 times 6 minus 50 is less than 0. And that's 16, which is positive. And anything positive can't be less than 0, so that's not part of the solution set. So in our equation, we can say anything from negative 10 to 5 is part of the solution set. But in the real world situation, we have to think about numbers like negative 10. If I plug in negative 10, I end up with a negative length. So for example, we plug in negative 10 minus 5, that would be a negative 15, which we can't have negative length. Which is not allowed. So we have to, in our real world context, we have to take in consideration that negative lengths are not allowed. So we have to only take in consideration from 0 to 5. So this is our real world context, because anything less than 0 would result in a negative length. And we are